Hi, I'm Oliver24. In this video, I'm going to be making a full game from start to finish. Obviously, to fit in one video, I'm going to try and make the smallest game humanly possible. And I decided Tic Tac Toe, or noughts and crosses if you're from the UK. I'll just show you what we end up with at the end of this video. So we end up with player versus player, and each player has a different colour, so you've got blue and yellow. The X and circle is assigned randomly at the start. The player who is X always goes first, and then when you place your X or circle, it's coloured in your colour. And when you win, it will change state and it will say who has won. If you draw, it'll say draw. And when you win, it will show you with a line how and where you have won. So we're going to be learning about different states of your game. We're going to be learning how to have player 1 win, player 2 win, and also how to have a draw. We're going to be learning about how to reset the game. And we're going to be learning some different UI elements as we piece things together. So this tutorial is mostly aimed at beginners, and it's going to cover step by step what I'm doing, how to do it yourself, and why I'm doing it the way I'm doing it. Hopefully, by seeing the whole process from start to finish, there'll be lots of things that you can transfer onto future games that you work on. If anything's confusing though, please let me know in the comments and I can give you a bit more information or help you out if anything isn't explained. So I'm going to hop into Unity and make a start. Okay, so I'm using Unity 6 for this, and I'm using a Universal 2D project. I'm just going to give it a name, so I've called it Tutorial Tic Tac Toe. I've given it a location, and we're going to start. I'm not going to connect to Unity Cloud, because that's usually for like multiplayer services. So when you're happy with that, just click Create Project. So here is our empty Unity project. The first thing I'm going to do is go to Scenes and delete the sample scene. And then I'm going to right click, go to create, and create a new scene. And this will create an empty scene, and we're going to call this gameplay. Then I'm going to double click it to open it. And I don't want to save the sample scene that we currently have open. There we go, we've got a new scene with a main camera, and it's called gameplay. Now since this game is mostly UI elements, I'm going to do it all on a UI canvas. So I'm going to right click, and I'm going to create a UI canvas. I'm just going to keep the name canvas for now. So I'm going to save the scene, which you can do by pressing Ctrl and S, or you can go to File, Save, and that saves the scene. And then I'm also going to save project. I do this all the time, just in case I lose anything. So it's always a good one to remember to do. Now in terms of what we need to do this project, there's a couple of things I have downloaded ready that I'm going to add into the project. You can add them as well if you like. So I'm going to right click, I'm going to go to Create and Folder, and I'm going to call this Fonts. And then I'm going to right click again, Create, Folder, I'm going to call this Art. Cool. And then in our Fonts folder, I'm just going to right click it and then Show in Explorer. This will open up a new window that has your folder selected. So I'm going to go into my Fonts folder. And then into here, I'm going to drag in a font file that I want to use for this project. So I've downloaded a font, I'm going to drag it in now. It's an OTF file. There's either TTF or OTF, and both will work fine. I can't give you this font file because of the licensing, but you can use any font that you like for your project. Next, I'm going to go back to the project, I'm going to click on Art, and I'm going to do the same. I'm going to Show in Explorer. Then I'm going to double click on Art to open it up, and in here, I'm going to add some paper textures that I downloaded. I can't give you these files either because of licensing again. I have a subscription to Envato Elements and it has fonts, stock images, photos, things like that. But if you just Google paper texture, you should be able to find some that you could use for your game if you want to do it in the same style. And then when we click back into Unity, it will import all of those texture files that we just added. Cool, so they're added in there. The next thing I'm going to do is find a colour palette to use for the game. So I've found this palette called The Perfect Palette on lowspec.com. I can put a link in the description below. And this one just has 64 different colours that cover the entire spectrum of colours. It looks pretty good and I think it should do for everything we need for this game. The reason I like to use a colour palette is because I'm not great at colour theory, and so picking colours I find really difficult. So I find that if I use a colour palette, usually the colours will go together really well and I can make the game look better without having to pick colours on my own. So I've taken a screenshot of this and I'm just going to save it into our project folder. So I've just navigated to the project folder within this window and I'm going to save it into the art folder. I'm just going to call it colour palette and then save. Now that it's saved in here, when we go back to Unity, it should be added. And we can just double click that whenever we need and it will open it up in a new window and we can have a look and see what colours we've got. And it's got all the hex values as well, which is really useful. So that's all we're going to need: a colour palette, paper texture and a font. You can get all those for free off of Google. Maybe not the exact same ones I've got, but that doesn't matter too much. So now I'm going to click File and Save again and then Save Project. Now if we go on Canvas, we're going to right click it and we're going to add a UI image. This is going to be our background for the entire screen. I'm going to call this paper background. And then onto here, I'm just going to drag our different paper textures and see which one that I like. So I dragged in paper 1. I'm just going to make this 1920 by 1080. And then actually, if we look at our paper, it's a square. It's 2048 by 2048. So I'm just going to do 1920 by 1920, just so I get the right ratio on the image. I'm not keen on this texture, so I'm going to skip on to the next one, paper 2. I quite like that. Okay, so I'm happy with this as a texture for the background for our game. The next thing I'm going to do is Ctrl S to save and then save project. Next, I'm going to add in our grid. So to do that, I'm going to right click and then I'm going to create an empty child, which I'm going to call grid. And I'm going to make it 1080 by 1080 for now. And then I'm going to right click on grid and then I'm going to make a UI image. And this is going to be one of the squares. So I'll just call it square. Now for this, I'm going to drag it into our project to make it into a prefab. So I'm going to go back to assets. I'm going to right click. I'm going to click create and folder and call it prefabs. It's good to try and be as organized as possible with your folders. So art, fonts and prefabs are ones that I usually make. So I'm going to jump into prefabs and then I'm going to click and drag our square into here. I'm going to rename it to grid square, just so it's a bit more obvious what it is, because square is a bit vague. I'm going to rename this as well to grid square. And we're going to need 9 of these, so I'm going to press Ctrl C with it selected, and then Ctrl V, 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 until we've got 9 of them. So that should be 1, 2, 3, 4, 5, 6, 7, 8, and then 9 for the first one. Now they're all stacked on top of each other, so what I'm going to do is go onto our grid and I'm going to click on here and then do grid layout group. And that should organize them into a grid if we do a few changes here. So we're going to do start corner upper left is correct. Child alignment, we want to do middle center. Start axes is horizontal, that's correct. For our cell size, let's change this to 1080 divided by 3. And then for Y, we'll do 1080 divided by 3 as well. Now, this just looks like a white square, but it's actually 9 of our squares set up. And then I can change this from flexible to fixed column count, and we know we want 3 columns. So I'm actually going to make these a bit smaller because at the moment they take up the full screen, and we're going to want some text at the top and text at the bottom. So I'm not going to make it the full height of the screen. I'm going to do, let's say, 960 by 960 divided by 3, so that's 320 by 320. That's still a bit big, so let's make it even smaller. Let's do 250 by 250. That looks good. Let's keep that for now. Now we can either do spacing here, or we can just make the art assets individually a bit smaller than the full square. So I'm going to do it that way. So if I go to our first square grid, we can actually turn off this image because we're not going to need to see an image on this object. So I'm going to click overrides and apply all. Cool. And then I'm going to add a child to this object, which is going to also have an image for now so we can see it. And then I'm going to make this stretch, and I'm just going to add in a border of 10 to each size. And then I'm going to go back to grid square, overrides, apply all, and that will make the changes to our prefab, which means all of these different objects will all get the same changes, which is what we want. And that's the advantage of using prefabs, is you can make one game object and then everything can be the same as that game object. You can have multiple copies within your scene. So I'm going to save, Control S, and then save project as well. The next thing we're going to need is our circles and crosses. So to do that, I'm going to do it using a Text Mesh Pro object. So I'm going to click on my grid square, I'm going to go down to UI, and I'm going to add a Text Mesh Pro for our noughts and crosses. And then I need to import our TMP essentials so that we can use Text Mesh Pro. Text Mesh Pro is just a really nice way of doing text within Unity. So now that I've imported that, I can use it. So I'm going to make my font black so that we can see it on the white. And then I want to change the font to the font that we chose earlier. So to do that, I need to click on the font, right click it, and then go to Create Text Mesh Pro Font Asset SDF. And that will make a Text Mesh Pro version of that font, which means we can now go back to text. We can click and drag our Text Mesh Pro version font onto our font asset within the Text Mesh Pro component. So you can see there that it's changed the font to the new one that we've chosen. Now if I just change this to an X, we can see how that's going to look. We can also put an O in as well, so we can see those next to each other. I'm then going to change this from centering in the middle to scale, so it scales with the size of the square. And then I'm going to change all these to 0 as well. Next, I'm going to center the font and then put it in the middle of the height. Then I'm going to change the size so that it's really big and takes up most of the square. So I think maybe 300 should do that. Let me try with just an X. That's too big. Let's make it 250. And let's try an O. That works as well. Cool. So I'm going to put in an O and we'll leave that as that. We'll then change the name of this object to O. And then we'll go here, we'll copy it and we'll duplicate it. And then we'll change this one to X. And then we'll put an X in this one. Cool. And then we'll click back on grid square. We'll go to overrides and we'll click apply all. So now all of these squares on our grid have got a circle in them and they've got an X in them. And they have an image for the background of the square. Next, I want to add some grid lines in. So to do that, I'm just going to go back to our grid and I'm going to add a new UI image and I'm going to call it grid line. I'm not going to make this a prefab because it's not going to have any code. It's just going to literally be a black square. And now you can see that it's the same size as our grid squares and it also takes up a space and pushes the grid up. So that's because it's a child of grid. I want to click it and drag it so that it's not in grid, it's just in canvas, and then I can lower it so that it's below the grid. There we go. Now I can resize this and also set its anchor to be middle center. And then I'm going to put it to 0 on the x-axis and 0 on the y-axis. And I'm going to change its scale so that it is 5 high. And then we can set our width to 750, which will be the full size of our grid. And then I'm going to raise it up until it is in the right place, which is 125 upwards. And then I'm going to copy this, paste it, and then I'm going to lower it to minus 125. And then that's our top horizontal line and our bottom horizontal line sorted. I'm going to rename this to visual grid line, just so I know it's visual and it doesn't have any code. I'm going to name this one to visual grid line 2. And then I'm going to copy both of those and paste them. Then I'm going to name this one to gridline 3 and this one's just going to be gridline 4. So for gridline 3, we're going to resize this one. So it's going to be 5 wide by 750 high. And that'll be the full height of our grid. So we want to put that to Y is 0 and our x-axis is minus 125. Perfect. And then on grid line 4, we're going to do the same. So our height is going to be 750, our width is going to be 5, y-axis is going to be 0, and our x-axis is going to be 125. And then we've got our grid in place. I'm now going to click all of these objects by clicking one and holding shift and clicking the bottom one, and then I'm going to click create empty parent. This will put all of our grid lines into one object, which we can call grid lines. Cool. Cool, so now we have a grid and we have our individual squares. So I'm going to save the scene and save the project. Awesome, now we're going to do some coding. So I'm going to right click in our scene, I'm going to go to create empty, I'm just going to call this managers. And this is going to be a game object that holds our scripts on it. And then I'm going to create a new script called Game Manager. Now, Game Manager is usually a script that controls the overall game flow of your game. So it handles things like starting a new game, checking if somebody has won, loading new scenes, of restarting the level, just general things like that. Once that's done, we can right click it and then click Edit Script. Awesome, that's loaded. I'm just going to zoom in a bit so you can see it a little bit better. I'm going to delete this code that Unity puts in for us because we don't need it for now. And then Ctrl S to save that. Next, I'm going to go back into Unity. I'm going to make a new script on our grid that is going to be a grid manager. Grid manager. And this is going to handle all things related to the grid itself. So our game manager will interact with the grid manager, and the grid manager will actually control and take care of this grid. Right click it again, click Edit Script, then I'm going to delete this template script that is added automatically. So for this, we actually are going to want quite a few things. So we're also going to want an individual grid square manager. So if I go back again, go onto our grid square, I click Add Component, New Script, and we're going to call this Grid Square Manager. And so what these different scripts are going to do is our grid square manager will only be in charge of handling what is displayed in one individual square on our grid. And then our grid manager will be in control of the overall grid, and it will interact with each of those individual squares and tell them what to do. And then our game manager will handle overall big picture things, which will also interact with our grid manager. So now if we go to our grid square and we open up our grid manager script by right clicking and clicking Edit Script. Again, we can delete this code that Unity puts in by default, and we're going to want a few things on here. So if I open our grid square game object, we can see it has an image and it has two TextMesh Pro game objects. So go back into our script. We're going to want a serialized field, which means it's private, but it shows up in the inspector so we can see it and edit it. And then we're going to call it private. Now, private means that you can only access this from its own script, which is what we want. Public would mean you can access this from any other script, and you should only use that if you really need to use that. Otherwise, you should stick to private. And then this is going to be a TextMesh Pro UGUI, and that is our TextMesh Pro component. I'll do an underscore because it's a private variable, and I like to do that to keep everything tidy. And then I'll call this O-text. And then we'll also need a serialize field, private, TextMesh Pro, and we'll call this X-text. And then we're going to create a public enum that we're going to call grid square state. And this is going to be either empty or X or O. And that's the different states that our grid squares can be. And by default, we want our grid square to be empty. So we're going to do a private grid square state, and we're going to call that current state equals, and we'll do grid state empty. And that means that by default, our grid square will be empty and have nothing in it. And then we're going to want a way of changing what our grid square shows. So we're going to do a new method which we're going to call setSquare. And this method is going to need to know what grid square state we would like to set, and we'll call that a new state. So new state is the name of the grid square state that we're going to use to define what we should set our square as. And the reason it has a red squiggly line is we need to do curly lines which contain the code that will happen when this function is called. We also need to add whether this is a public method or a private method. This is actually going to be a public method because it'll be called from our game manager script. So we're going to have public for that. And then you need to return something. So I'm going to return void because we don't need to return anything. And void is the same as null or the same as empty. So it means do not return anything. And then if the new state equals grid square state dot empty, we know that we're going to want to disable our oText.enabled equals false and our xtext.enabled also equals false. Then we're going to want to do else if our new state equals grid square state.x. Then we're going to want to do oText.enabled equals false and xtext.enabled equals true. And then we're going to want to do else if new state equals grid state square dot o, then we want to do oText enabled equals true and xtext.enabled equals false. So when we call set square, we tell it what our new square state should be, and then if it's empty, we're going to disable our o and our x. If it is x, we're going to disable our o but enable our x. If it's o, we're going to enable our o but disable our x. Perfect. So our variable here is going to be a list of grid square managers that make up the whole grid. So we can do that by going private grid square manager and then do square brackets to make it an array, which is a list of objects, and we can call that our grid. We're going to do the same thing. We're going to serialize field so that this shows up in our inspector, and then we can save this. Now if we go back into Unity once that's saved and compiled, we can go to our grid square, we can override and apply all, and then we're going to want to set our o text and our x text. So if I click on our o and drag it into our o text there, it'll add a reference, and we click on our x text and we drag it in, we'll have a reference to our x there as well. And then we want to override and apply all. And now all of these different squares will have a reference to their own x and their own o components. So now if we go back to grid, we can get a reference to all of those different squares by adding in each of our squares here. Or if we click the lock here on inspector, we can lock this window, and then we can click on the first grid square and hold shift and click on the last one, and then if we click and drag all of them together into our grid, it'll have a reference to all of them in order. If we unclick our padlock here to unlock it, click on our first grid square, it'll be the first one in the grid, and the next one along is this one, next one along is this one, and so on throughout the grid. So we can use that to know that element 0 is this one, element 1 is this one, element 2 is this one, and then you got 3, 4, 5, 6, 7, 8. And then in code, we know how to access all of these different squares to see what they are. So now what we want to do is go back to our grid manager, edit script, and we're just going to add a new function called public reset grid. And this is going to be a void because we don't need to return anything. So now what we want to do is go through each grid square manager within the grid and reset it to be empty. So to do that, we can go for each, and then we can do grid square manager, which we'll call square in underscore grid. So for each square in our grid, we're going to want to do square dot set square, and then we can set it to grid square dot empty. So that will empty every square in our grid. And then on public void awake, which is called when the level first loads up, we can just call reset grid. So that whenever we press play, our grid should hopefully be reset. And we can go back to Unity now, and if we click play, our grid is reset. Perfect. Next, I'm going to click back on our grid square and I'm going to make our image invisible. And then I'm going to click back on grid square and then just apply that, because we don't necessarily need to see where the squares are now that we have lines to show us. I'm going to click play again and you should see that our grid is completely empty. Yeah, that has worked. Perfect. Awesome. So now in managers, we're going to want to right click again on game manager and edit script. We're going to need a few things in here. So we're going to need to know whose turn is it. Is it the player's turn or the enemy's turn? Or the other player, depending if you're playing against another player or a bot. So to do that, we're going to create another public enum and we're going to call this turn. And it's either going to be the player turn or enemy turn. And then close brackets. And then in here, we're going to want to know private turn, current turn. And I'm going to do an underscore under that as well. So now we're going to do a new function of what happens when the game starts. So we're going to call this private. We're going to call start new game. And then we're going to do curly brackets. And in here, this also needs to be a void because it doesn't return anything. And in here, we need to choose at random, is it the player's turn or is it the enemy's turn? So we're going to want to do random.range between 0 and 1. So that will choose either 0 or 1. And we'll make this a new variable that will be int first turn equals random range from 0 and 1. And then we can actually make the current turn equal to first turn. To do that, we need to cast that to turn. Okay, so this looks a bit confusing, but what we're doing is picking a random number between 0 and 1. And you can see here that if we hover over it, the min is inclusive, the max is exclusive. So actually, we need to put 2 there. So that means that it will either be 0, 1, and it can't be 2 because 2, the max, is exclusive. So it will pick a random number between 0 and 1. And then our current turn will be set to the turn value of 0 and 1. And this basically means that player turn, if you hover over it, equals 0. Enemy turn, if you hover over it, equals 1. So if we're picking a random number between 0 and 1, we either get our player turn or our enemy turn. And then we know whose turn it is first. So in awake, we're going to make a new function called awake. And in here, we're going to do a start new game. So once the game loads, it will start a new game on its own. We can also go back to our grid manager. We can take this function out of here and we can make a reference to our grid manager from our game manager. So we'll put private grid manager and we'll call it underscore grid manager. And then we'll make that a serialize field so that we can set it in the inspector. So if I save that and go back to Unity when it's loaded, we can now go on our manager scripts and you can see that we've got no reference to our grid manager. So we just want to grab our grid from the hierarchy window over here and drag it into our grid manager reference on our game manager script. So now it has a reference directly to that. And then that means if we go back into our scripts again, we can go to start new game. We set our first turn and then we can also call our grid manager and we can do dot reset grid. And then that means each time we start a new game, we're going to reset the grid. We can probably call that before we choose whose turn it is as well. So one thing I'm going to do here is start adding in some comments. I'm going to put here, reset the grid to clear all squares. And then we're going to randomly choose who goes first. So we keep a track of whose turn it is. We randomly choose whose turn it is when we start a new game, and we clear the grid when a new game is started. We're going to make a new method called private void process turn. And to process this, we need to know two things. We need to know whose turn it is, so we'll call it turn, and we'll also need to know which square they have clicked on. So if we do an int selected square, we know that from 0 to 8 are the different squares on our grid. And then if we know whose turn it is and what square they've clicked on, we can call our grid manager and tell it to set that square to the value that has been clicked. So if we go to our grid manager, we need a new function called public void set specific square, and then we're going to need to know whose turn it is, so turn, and we're going to need to know which square to set, so int square. And once we know both of those things, we can do grid, and then we can put in our square number to get the correct square, and then we can do dot set square, and then we need to know the state to use. So actually we need to convert our turn into noughts or crosses, because we can't just put our turn into here, because we need to know what grid square state we should be using. So if we save and we go back to grid square manager, basically whoever goes first is usually the X, and that's the way we're going to do it. So once we go back to game manager, when we assign which player goes first, we should also assign X to that player. So to do that, we're going to do private grid square state, and this is going to be player square state. And then we're going to also have a private grid square state, which will be our enemy square state. And then we can go down to where we assign who goes first, and we can do if first turn equals 0, which means player turn, then the player square state equals X. So our player is X, and our enemy square state equals grid square state dot O. And then we can do else player square state equals grid square state dot O, and our enemy square state equals grid square state dot X. It's put in double equals there, so we can just delete one of them. Assign grid square state to player. Perfect. So now in here, actually, we don't need to know whose turn it is. We just need to know what grid square state has been selected. So we can call that grid square state. And then when we set our square, we need to know what grid square state to set. So that'll set it to either a naught or an X. So now when we process a turn, we need to call our grid manager, and we will do set specific square, and we need to work out what square state to set and also the square value. So we can put selected square as the value of which square to select, and then to know the value we need to know whose turn it is. So if turn equals turn dot player turn, else, and then we know it's the enemy turn. And then we're going to do here grid square state equals, we'll just make it empty to begin with, and then if it's the player's turn, we will set state equal to, and then we need to know what the player state is, and we set it to that. Else we set it to the state enemy square state. There we go. And then if we go here, we just put in the state, and then we pass through whose turn it is. We don't need to know anymore, but we know whether they're an X or an O, and we pass that along to our selected square. So the next thing we need to do is to have a way to choose which square you want on the grid. So if we go back to Unity, we go to our canvas, we go to our grid. If we go back to our grid square manager, we can tick our image back on so that we can see it, and then we can change its transparency to 0. And then if we override apply all, we're going to basically turn this into a button that when it gets clicked on, it will send a message that says I've been clicked on, and then we can work out what to do with that. So now if we go into our grid square manager, edit, script. So to do this, we need to add here, we need to add iPointer click handler, and this will let us click on this game object. And it's red and squiggly because we haven't added in the methods we need to add to use this. So if we go to quick actions and refactoring, we can see that we need to add a using Unity engine .event systems. So we can click that and it will use the event system. And then we click it again and we see that we need to implement the interface. So if I click that, it adds this on pointer click event data. So in here, we're going to add what we want to happen when you click on this object. We're going to want to send a message to our game manager and tell it that this object has been clicked. So what we're also going to need is a serialize field private int, and we call this square ID, so we know which square it is. And then we can go to our game manager and we need to turn it into a singleton so that only one of these game managers exists, and then that way we can send messages to it. So to do that, we're going to have a public static game manager, and you could call it instance, but what I like to do is just do an underscore. So this means a new game manager called underscore, and if we set that to this game manager, we can have only one of them in the scene because it's static, and that means we can reference it from anywhere else in the game. So when we're in awake, we're going to want to do underscore equals this. But we're only going to want to do that if underscore equals null, and you do two equals because you're checking does this equal this. And if so, we will do underscore equals this and then continue. You can do here else debug.log error, and then in speech marks we're going to put there are more than one game managers in this scene, because there should only be one because it's a singleton now. So now that we've done that, we can add a new method here that is private void grid square clicked. And for this we need to know int which square, or int clicked square. And for now we'll just do debug log, and we're going to call this, and in speech marks we're going to write square clicked equals, and then we'll do plus and clicked square. So it should log which square has been clicked on. And we can make this a public void because we need to access it from the other script. If we go back to our grid square manager now, we can call game manager dot underscore, which references our only version of the game manager within the scene, and then we can call grid square clicked, and we need to know which one it is, so we can do our square ID and tell it which square has been clicked. So now if we go back into Unity, once it's loaded, we can go to our grid square. This one has a square ID of 0. What we can do now is we can either, in each one of these, we can type in the correct number for it, which is fine, or we can do it in code. I'm going to do it in code so that we know it's correct and there's no human error. So I'm going to stop this square ID from being a serialized field and then save it. And now the ID should disappear from in Unity Inspector. It's gone. And then if we go to our grid manager, edit, script, what we can do is we can change this for each and change it into a for int I equals 0, I is less than the grid length, I plus plus. This is called a for loop, and basically it means I equals 0 and I goes up to the length of the grid, which is 9, and each time it goes around this loop it adds 1 onto I. So I starts as 0, it does a loop, it increases I to 1, it goes again, increases to 2, goes again all the way up till it reaches the length of our grid, which is 9. So it goes through this loop 9 times. And since it goes through this group 9 times, we can do grid dot, and then in square brackets we put the I value, so we can get the grid square at value 0, then the one at 1, then the one at 2, then the one at 3, and so on. And each time we do that, we want to set square grid square state to empty. But also we're going to want to do grid I dot, and we'll do a new method called set square ID, and into that we'll pass I. So we'll go back to our grid square now, grid square manager, and we can do a new function called public void set square ID. And then for that we just need to know what the ID should be, so we'll have an int called ID. And if we know that, we can set square ID equals the ID. And that will set our square ID for each of these squares to the value that we pass into it. So now if we go back to our grid manager, it'll pass in the I value into the individual squares. So we don't have to set that manually anymore. It'll get set by default by Unity in our code. So if I click play now, they should all get set to empty, which has worked. And then if I click on each of these, you'll see 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can see that each of these squares, when clicked, sends a message saying which number has been clicked. Perfect. Awesome. Now if we go back to our game manager, we're going to want to know when we are listening for an input and when we're not listening for an input, if that makes sense. So we don't want these to be clickable at any time. We only want these to be clickable when it's the player's turn. So we can do that by using current turn. We can go here, we can delete this now since we know it works, and we can add in an if current turn equals turn dot player turn. Then we know what to do. Else if current turn equals turn dot enemy turn, then we know what to do. What we're also going to add here is a private bool called awaiting input, and this will basically be true when we are waiting for the player to press something. So we go here and we're going to do if underscore awaiting input equals false, so we're not waiting to know what has been clicked, we're going to do return. And that just means if we get to here and it's not awaiting an input from the player, it just returns void and it just skips any code afterwards. So if we don't skip any code, we know we are waiting for the player to click. Or we're waiting for a player to click, because we might have a human player for the enemy as well as the player. So if we're currently waiting for someone to click and we know it's the player turn, we're going to want to process turn, and the turn will be the player turn, and the square they clicked is the clicked square. Otherwise we know it's process turn, current turn, clicked square for the enemy. Turn dot enemy turn. I mean, since these are basically the same, we could have put in the current turn instead. Let's do that. Current turn. We just put in the current turn and the click square. And then we can actually get rid of this because we don't need to know whose turn it is if we were waiting for an input. So I'll get rid of that. What we can do now is set awaiting input to be true at the start. So awaiting input equals true. And that will mean that once the game has started, it's waiting for us to click on one of the squares. We'll click on a square, it'll process return, and then at the end of this, we want to set awaiting input to true again, and then we want to change whose turn it is. Public void change turn. And so when we change turn, we want to do if current turn equals player turn, then current turn equals turn dot enemy turn. Else it'll be the opposite, and we'll do current turn equals turn dot player turn. And this will change whose turn it is. So we can call awaiting input true, and now it is change turn, the other player's turn. So now if we save all and go back to Unity, we can click play. I can click and we've got an X, click, we've got an O, click, we've got an X, click, we've got an O, click X, click O, click X, click O, click X. But then if I click on an X, it'll turn it into an O. And I can keep doing that, which is not ideal. And also there's no way to win. So like if I click on each of these, I can make them all O's or make them all X's. So we can end that now. So now it is taking turns between the player's turn and the enemy's turn, depending on who is going first and which one is the X and which is the O. Awesome, so now we need to know who has won. So we're going to go back in here, and after somebody has taken a turn, so process turn, we're actually going to want to do awaiting input equals false because we've taken a turn. We're going to want to know a few things. First of all, we're going to want to know, is the square that has been clicked empty? So we can do that here. Before we process the turn, we can check by going to Grid Square Manager, and we'll just add a new function, new method called public, and this one actually will send something back. It will send a grid square state back, and we're going to want to do get square state, and we're going to want an int square ID, and we're going to want to return the state of our, this is for the individual square, which is fine. We can call this grid square state, and we can just return the current state. Cool. And then if we go back to our grid manager, we're going to want another one here called public void get specific square state, and this will need an int square ID, and we can change this from void to grid square state, and then we want to return the grid, and then we're going to use the square ID to decide which square it is, and we're going to do dot get square state. And so we're going to return the state of the individual square on the grid based on the square ID. So now if we go back to game manager, we can do grid manager dot get specific square state of the clicked square, and we're going to do if that doesn't equal empty, grid square state dot empty, then we're going to want to return, because you can't click it if it already has something in. It needs to be empty. So if it is empty, we continue. So we check first, are we even waiting for an input? If we are, we continue. Is the square empty? No, we return. Let's just jump back into Unity and test that that works. So if I click play, I should be able to click anywhere. So I click somewhere, we've got an X. I should be able to click anywhere again and get an O. Now for X, if I try to click on the O, nothing should happen, but it does happen. So it shouldn't be possible to click on these squares. So what is happening there? Oh, okay, I figured out what the problem is. Basically, we never actually set the current state of this object to what is being clicked. So we need to go here, and at the end of this, we just need to go current state equals the new state. And then that should fix the problem where it was always thinking that the squares were empty, even when they weren't. But the reason for that was because we never actually set them to anything else. So if I click now, I can't change what those are and it'll still be X's turn, and then it'll be O's turn. I can't change those, and then O can go. So now I can fill a grid up. I can't replace any squares that have already gone, but we're not checking if win or lose has happened. So now we need to check for a win, or check for a loss, or check for a draw. So at the end of each turn, process turn, before we change turn, we're going to do check if game ended. So we're going to do private void check if game ended. And let's actually, instead of sending back a void, we will send back a bool. And here we'll do bool game ended equals check if game ended. If game ended, return. Otherwise, we change turn and await input. So if game hasn't ended, we can change turn and we can await input. Otherwise, we know the game has ended. So how do we know if the game has ended? Grid manager dot check if grid full, and then we'll go back to our grid manager and we'll do a new function called public void check if grid full. And how would we know if our grid is full? Well, we could do for each, and this will be a bool that we return. For each grid square manager square in the grid, if square dot get square state equals empty, then if there's an empty square in the grid, we can return false because we know there's at least one empty square. But if we go through the whole loop and none of them are empty, we can return true because we know the grid is full. So now if we go back to game manager, we can do bool grid full equals, and then we can do grid manager check if grid full. So we're going to check if the grid is full, but also there's more things we need to check. We need to check if the game has won, if it's been a draw, or if it's still ongoing. So to do that, I'm going to go down here and I'm going to do public enum game result, and I'm going to call that ongoing, draw, player win, or enemy win. And then I'm going to add private game result is current game state. So when we start a new game, our current game state equals game result dot ongoing. So we're doing a new method here called private bool check for win. Then we're going to want to check all the possible ways in which one of the players could have won. So to do that, we're going to do a new method on our grid manager called public bool check for win, and then we need to know int grid square 1, int grid square 2, int grid square 3. So we're going to check 3 different squares to see if a win has happened. And then we're going to do if grid square 1 dot get square state doesn't equal empty, which is great. We know then, in fact, let's just do grid square state 1, grid square state 2, and grid square state 3. We know state 1 is equal to grid square 1 dot square state, and then we're going to do equals grid square 2 dot get square state, and then for 3 equals grid square 3 dot get square state. Cool. And then we've got all 3 of the states, and we just want to do if state 1 doesn't equal empty, we know that at least that one doesn't have anything in it. And if that square has something in it, we can check if state 1 equals state 2 and equals state 3, we know somebody's won. So return true. But actually, instead of returning true, we could return here a grid square state, and we could return state 1. So we know who's won. Because if this is a circle, this is a circle, this is a circle, we can return circle and we know that circle has won. Else, nobody's won. So we can do return dot empty. And if it is empty, we can just return grid square state dot empty. I have to also put in here and state 1 equals 3. So it checks, does state 1 equal 2 and does state 1 equal 3? And then if so, on both of those, we know state 1 is the same on all 3 squares and that person has won. We know if that is not true, nobody's won. We know if one of the squares is empty, nobody's won. So if we go back to our game manager on check for win, and we're also going to make this a grid square state, we're going to do grid square state winner equals grid square state empty. Cool. So now we're going to go through each of the possible ways somebody could win in noughts and crosses. So we can do grid manager dot check for win, and we can check 0, 1 and 2, and that'll check the top row to see if there's a winner. Winner equals grid manager check for win 0, 1, 2. And then what we can do is if winner equals grid square empty, we know there's no winner, so we can continue on to the next one. If it equals X or circle, they have won. Okay, so we can do, if it doesn't equal empty, then we know return winner. If it's empty, then we can check winner equals grid manager dot check for win. We're going to check the next row now, which would be 3, 4, 5. And then we want to check again. If it's not empty, return the winner. And then again, we're going to do winner equals grid manager dot check for win. We're going to do 6, 7, 8. And we'll copy and paste this code again. Cool. So that's all our horizontal checks. Horizontal win conditions. Then we can do our vertical win conditions. And these are the same, so we just copy and paste these. And we change these to 0, which is correct, 3, 6. And that'll be the first top left, the middle left, and the bottom left. And then we can do 1, 4, and 7 for the middle row. And then for the last row, it is 2, 5, 8. Cool. And then we need to check diagonals. So diagonal win conditions. And for this, we only need 2 different diagonals. So we can copy and paste this. We can check for a win in 0. We need the middle number, which would be 0, 1, 2, 3, 4. And the bottom one is 8. And then we need to know the other way, which would be 2, 4 in the middle, and then 6. It would be 6. Cool. So this will check diagonally for a win, and it will return the winner if the winner is an empty, and this will check the other opposite diagonal. Cool. So now we check for our winner in all possible situations, and if there is a winner, it returns the winner. If not, and we get all the way down here, the winner is empty, so we can also just return winner. And the winner will now tell us who has won. So here we can do, so grid square state winner equals check for win, and now we can do a little bit of logic. We can do if winner doesn't equal empty, we have a winner, and then we can do if winner equals player square state, we know the player has won. We know player has won. Else we know the enemy has won. Enemy has won. Cool. So if the winner isn't empty, we know somebody has won. We know either the player has won or the enemy has won. Else, here, we can check if the winner is empty, nobody's won. We can check if grid full, we know it's a draw. So game is drawn. Else, the game is ongoing. Game is ongoing. Cool, and that's all of our different scenarios for checking if the game has ended. So if the game is ongoing, we know we can return false because the game hasn't ended. In any other situation, we know it is true. So we can return true, the game has ended. Game has won, we can return true. Game has won, return true. So in process turn now, we check, has the game ended? If not, change turn. If it has ended, that's it, the game has ended. We can change our state here, current game state, from ongoing to the actual result. So we know the player has won, so we can do current game state equals player win. We can go here, we know current game state equals game result dot enemy win. If we go here, we know the game is drawn, so we can do current game state equals game result dot draw. Otherwise, the game is ongoing. We don't need to change anything. So now let's press play again. So now if we test it, the game should keep playing until somebody wins. So we can test that quite easily by clicking X, circle, X. That's not a win, so the game should continue. And it's circle's turn, so circle goes there. X goes there, it's still playing. Circle goes here. Now if I press X here, the game should end. If I press here, nothing happens because the game has ended. X, circle, X, circle, X. Game has ended. Yep, that's true. Cool. So now we need a bit more UI to sort of show what's going on. So to do that, I'm going to add some extra text into our scene. So I'm going to go to Canvas, right click it, and go UI, text Mesh Pro. I'm going to call this player. Change the font to our font that we made. I'm going to call this player 1, and I'll put it as an X for now, but we're going to set that in code. Oh, sorry, I didn't make the settings on our canvas. I actually want to go back and change this to scale with screen size and 1920 by 1080. We're just going to make this center, and we're going to put it 0, 0. Width, I'm going to make a bit bigger than that. I'm going to make it 320. And height, I'll just make 50 is fine. I'm going to resize the font so it's bigger. I'm going to make it 64. That looks good. And I want this actually to be in the top left corner. So I know for that I probably want to do align left, top left, put that 0, plus 160. And then I'm just going to add a bit more, so plus 25. And then for the top, I want that to be 0. I'm going to add plus 25, because that's half. Oh, sorry, minus 25. Minus another 25. 50. So up there, we've got player 1 is X. I'm going to make that black as well. And then I'm going to copy and paste that. Player 2, I'll make that a circle just for now. And this will be in our top right corner, 0. And we know it needs to be minus 160 minus 25. And I'm going to change the text here so it's pushed to the right and this one's pushed to the left. And then actually what we could do is we could put that on the next line down. Okay, I'm going to delete the X from the player 1 bit and I'm going to go to the player 2 bit and delete the O as well. And we'll just have those as separate objects. So I'm going to put player label. And then for this one, I'm going to call this player label as well. Player label, player 2 label. And then I'm going to copy and paste the player label. I'm going to make that an X. I'm going to lower it down to, yeah, like minus 150. I'm going to make this font much bigger. Yeah, 300. That looks good. I'll raise it up a bit to minus 125. Nice. And I'm going to change this to player 1 character. And then copy and paste that to make player 2 character. 2 character. I'll make that a circle. And then we'll go over to the other side. So minus 185. Oh, we need to align it on the right and then minus 185. Should work. There we go. So in code now we need to set this X and this O. So if we go back to our managers and our game manager, we can just edit scripts. And in here we need references to our UI. So we can do a private text mesh pro. And we'll call this player character text. And we'll call this private text mesh pro UGI enemy character text. So now when we set our characters in our start new game, we know what our player is from this and what our enemy is from this. So we can call it here, we can call this set player character UI. And we just want to do player character text dot text equals player square state, because that will either be a 0 or an X dot to string. And this one, enemy character text dot text equals enemy square state to string. Cool. So now if we save it and we go back to Unity, this will either be X and O or O and X. So we've pressed play and it's X and O, which means X will go when I click. Oh, sorry, it says that I haven't set those objects. So if I go to Make Game Manager, we need to set these to serialized fields so they show up. And this one needs to be also serialized field. And then press save, and that will show both of them up here. And then we can drag our player 1 character into player text and player 2 character into our enemy. Okay, so when I click play, it'll either be an X for player 1 or an O for player 1. And for player 2, we'll also get an O or an X, the opposite. So X and O, we stop playing, we play again. We press play again. We might get OX this time. OX, cool. So it's random who gets which one each time. Now, what we're also going to add is we need to know whose turn it is. So I'm going to add at the top in the middle here. So if I copy and paste our player 2 label, whose turn is it? And we center this in the middle. We can call this player 1's turn. And we'll change the width to 640 so it fits. We can change that to current turn, and then it'll be player 1. Or we could do it like that. Current turn, player 1, X. And then we want to lower our grid down because we've just changed that. And then if I click on grid and click grid lines, I can just create a new empty parent, and then I can move the whole grid in one easy way by just dragging that down. So I'll make that -90. So we know current turn is player 1 and X. I'm just going to split that into 3 separate objects so I can change them dynamically. I'll delete that bit. I'll change that to current turn label, and then we'll have a copy paste, and I'll lower that down to -100, and I'll change that to player 1. Actually, I'll make it -125, so it's a bit lower again. There we go. And then I'll copy and paste that, and I will make that into an X and lower that to -250. It would be, no, that's too far, 175 -25. There we go. And then I want to resize this so it's bigger and make it 120. That looks good. And then I'm going to lower the grid a bit more, -130. And I need to set these two in code. So I'm going to go back to our game manager. I'm going to add 2 more text mesh pros. We're going to add serialized fields, private, text mesh pro, current player number, and then we're going to have serialize field, private, text mesh pro, current player character, text. Cool. So when we go down to change turn and we assign somebody's turn, let's add a new method called public void, or private void even, private void set current turn UI. And so to do that, we're going to want to set our current player character text to player, and then we're going to need to know plus which number player it is. We're going to want to do an int player number equals 0, and we'll do if current turn equals player turn, then player number equals 1. Else we know player number equals 2. And we also want string player character equals player square state dot to string, and string enemy character equals enemy square state to string. And then we can do, oops, I spelled this wrong here. We can do current player character text equals player square state dot to string. And we need to do dot text there as well to fix that. And then this one we do the same. The current player character text dot text equals player square state to string. And we also know that the current player number text dot text should equal player number to string. And then we don't need this bit here, and we actually don't really need this bit here. We can just take this bit, delete it, put it here, and we know it equals 1. And if this bit, we know it equals 2. Cool. Well, we can put player 1, and here we can put player 2. We want to set this UI each time we change turn. So change turn, and then we set the UI for that turn. And also, when we start a new game, we want to set the UI here as well. Now if we go back to Unity again, we're going to go to our game manager. We need to set the current player number text, which is that one. So current turn label 1. And the character, the X, is label 2. We'll change that to current turn player number. We'll change this to current turn player character. So now it says player 1, X is the current turn, and X is our player 1, player 2 is 0. So if I put an X, player 2, it still says X, it should be 0. It stayed the same. Let's jump back into here and see why would it have stayed the same. Oh, it's because I haven't changed this here to enemy square state. Because it's player 2, which is our enemy. We called it enemy player 2 just to kind of make it clear that player 1 is our player 2 is enemy. Because enemy could be a human, it could be another player, it could be anything. But for now we're just doing, I guess, local co-op where the other player is also another player. So X, player 1, X, now it's player 2's turn 0, player 1's turn X, player 2, O, and we probably want a restart button as well. So let's right click on our canvas, go UI, and we will add a button, Text Mesh Pro, and we'll just put this in the bottom right of the screen, 800, lower it down, somewhere around there, minus 500 will do. Let's make it bigger, 100, that's too big, let's make it 50, that's okay. Make it wider, 320. That's way too big. 240. I'll do. Make this a bit bigger, actually, 75. And then we'll raise it up again. Cool. Let's do minus 450. Let's do high. That'll do. And then in terms of how far across, 840 minus 25. There we go. I'm gonna make this button have the correct font on it, unless we already did that. No, let's drag in our font for that. Make the font bigger, we'll do 32, and we'll call this restart. Okay, so let's hook up our restart button. So on click, we're going to want to send a message to our game manager that just says start a new game. So we can do that very easily by going onto our button, dragging in our manager game objects here. We need to click plus first. Drag in managers, go to game manager, and we're going to click on start new game, which I can't see, which means it's private. So we need to go into that and make that public. Yeah, it's private. Actually, what we could do is we could make a new public void restart clicked, and then that just does start new game. Then we go back to Unity, go to our button, go to our button on click. We drag in our managers to that. We go to game manager and we click restart clicked. So now when this button is clicked, it will call restart clicked on our game manager, which will start a new game. We can try that button out. So if we press play, let's try just clicking this a few times. You can see it changes whose turn it is and who X and O is. Well, it doesn't change X here because X always goes first. Cool. So we can put a few squares in, we can click restart, and you see it restarts it ready for the next game. So what else do we want to add to this? We want to display the result, I think would be quite important. So what we can do is these labels here for the current turn, we could group them all together under a new parent. We'll call this current turn UI. And then by enabling and disabling that, we can turn that on and off whenever we like. We'll just duplicate all this. Duplicate. We'll call this game results UI. We'll just enable that, and we will just delete the top two, so we've only got the bottom one, and we'll make it even bigger, so 240, raise it up to -50, and this is going to say X wins, or O wins, or draw, and those are the three different things it'll say. So let's just leave it at a draw so we can see visually what's going on, and then we're going to go to managers. We're going to add a few extra stuff into our game manager now. We're going to want a serialized field, game object. This is going to be our game results UI, just like that. And then we're going to do serialized field, game object, our current turn UI. And then we're also going to want a serialized field, private, text mesh pro, game result text. Then I'll just put private in here because these are private as well. You don't have to write the word private because it's private by default. It's just better to type it so you can see. Cool, let's assign those now so we can see. So our game result UI is this game result UI game object. Our current turn UI is this one. Our game result text is this current is that one, but we can rename that to game result UI text mesh pro. Then in our script, if we just go back to managers and then game manager, when we start a new game, we want to, oh, it even says game results UI.setActive, and we want that as false. It was one of the suggestions. And then we want to do current turn UI.setActive is true. And then we're just going to copy and paste these into, if the game has ended, then we need to display the result. So I'm actually going to call here, if the game hasn't ended, else it's ended. So we want to set the game result to true and set active this to false. So we're going to set the game result UI to true and the current turn UI to false. So it'll just display the result. But on here, we need to set the text of what the result says. So if the player has won, we're going to write game result text dot text equals player square state to string plus wins. If the enemy has won, we're going to copy and paste this line in here, and we're going to have enemy square state wins. If it's a draw, we're going to paste that in, and we're just going to change this to say draw. Cool. And if the game's ongoing, it will just continue. So now if we press play, this should change back into our current turn UI because we've started a new game. So current turn is player 2, X, circle, X, circle, X. Let's make it a draw first. Oops, never mind. 0 wins because there's 0 noughts, and noughts is player 1. So restart, and it goes back to this. Player 1 is X, circle, X, circle, X, circle. And we'll make X win. X wins, which is player 1. Restart. Now we're going to try for a draw, if I can do it right. So 0, we should put there. X, we should put there. 0, we should block that. X should go there. O go there, X there, and it's a draw. Awesome. So we have knots and crosses working. Obviously you can add more polish, like you could change colors of things. This video is quite long, but I'm just going to add a little bit of extra polishing because I think it'll make a bit of a difference and it's worth doing. So we're going to add some colors into our design. So first thing I'm going to do is change the paper color. So let's go to our paper background, and we're just going to change this color to one of our colors from our palette. I'm going to try a few of them out, but this one might work. BE003D. That looks pretty good. Cool, I like that. So now we need to choose a different color for player 1 and for player 2. So if we go to our player 1 character and label, we can change the text color. So I'm going to maybe do blue and yellow for our different players. So for the blue, let's choose one of these blue colors from our palette that we have. Probably a bright blue to show up on the dark red. 4ADEFF. That looks pretty good. I like it. We can also go to our font and we can add an outline. So let's add a black outline. It'll add it to everything is the only thing to be aware of, but that's okay. No, I don't like that. You would need separate font files for each one for it to work. Let's not add an outline. Let's add a underlay, which is like a shadow, and we're going to offset it by 1 and 1. No, 1 and -1. That's quite far actually, so maybe 0.5 and -0.5. Awesome. And we're going to change this to one of our colors as well from our palette. So 6F102E. Yellow looks quite cool then, but let's keep this as a darker red. I'm going to try a brighter red though, just because when it flashed yellow, it looked pretty cool. F6092F. That looks cool. Let's leave it like that. And then we're going to set player 2 to yellow. So if we go to player 2, we scroll up, we change the vertex color to a yellow color from our palette. Let's try F6D000. That looks pretty good. Let's keep it at that. Now we probably want to change these X's and O's to the color of the player. So to do that, we're going to go to our managers. We're going to right click on Game Manager, Edit Script. We need to add our colors in here as well. So we're going to add serialize field. We're going to add private, color, player, color, and same again, but enemy color. There we go. So if we go back in here now, we can add those colors in here. So for the player color, I can just pick it from here. It's this one. And then for the enemy color, I'll pick that. That's the yellow color. Cool. And I'll save again. Save, save. And then we'll go to Game Manager, Edit Scripts. So now we need to do a few extra things. We're going to go to our Grid Square Manager. And in here, when we set the square, we're also going to want color, new color. And then we can do oText.color equals new color. And also our xtext.color equals our new color. Because it doesn't matter if we set them both to a new color, because we're enabling and disabling the correct ones anyway. We could actually set them before we disable them, but it doesn't really matter because it's all happening in the same frame. So we'll leave that there. And then that means that if we go to our grid manager, this will now be incorrect because we need to know what color we are setting it to. So we need to know also color, color, and then we can put here set square, and we can add our color into that. And then this is saying empty, and our color for empty could just be color.white because it doesn't matter. And set square here, empty, so we could do color.white. And actually this code here we can delete because we basically did the same thing here. So let's just delete that one now. Save. And if we go back to Game Manager, we'll see some errors here. We need to choose what color here. So process turn, we need to know whose turn it is, and then we need to know the color. So we can put here a new color. Color equals turn color equals color white. And then if it's the player turn, we'll do turn color equals player color. Else the turn color equals the enemy color. Enemy color. And then when we set the color here, the square here, we can just add in our turn color and pass that along. So now if we jump back into Unity, we can test this out. So our player 1 is blue, our player 2 is yellow. We can even change these as well if we wanted, so let's change those afterwards as well. So it's player 2 X, we press X, it's yellow because it's player 2's. O will be blue, X, O, X, X wins. We can change that as well to our correct colour. So let's stop that. Let's now change these bits to the correct colours as well. So if we go to our scripts, so if the player has won, then we want to do game result text.color. Yeah, text.color equals player color. If the enemy has won, we will do equals enemy color. If it's a draw, let's equal it to color.black. If we scroll up to set the current turn UI, if it's player 1's turn, we know we want to do current player number text dot color equals player color, and the same with current player character text color equals player color. And then we can just copy paste that into here. And we know we want to do enemy color instead. Enemy color, enemy color. Play. So we click here, player 1, player 2 yellow, player 1 X blue, player 2 yellow, player 1 X, player 2 yellow, X is 1, X wins, is in blue. We restart, let's try and get a draw. X go there, circle block that, X there, draw, in black. Restart. X wins yellow because it's player 2. There's obviously like lots of extra polish you could add, like you could draw a line over what has won. So like, let's make a win. We could here add a line through showing what has won, or a line across, or a line diagonally. Let's do that. Why not? In our grid lines, we'll do it. We'll copy and paste grid line 4. We'll make this white so it shows up, and we'll make it wider. We'll make it like 10, and then we'll set it to 0. So that will be vertical middle win. We'll copy and paste that. We'll call it vertical left win, and that will be minus 250. Yep, we'll copy and paste that. We'll call that vertical right win. We'll put that at 250x. We'll copy and paste this all, and then we'll call these horizontal. Horizontal middle win. Horizontal top win. This will be horizontal bottom win. Top win. Bottom win. And then these horizontal ones need spinning round, so 750 by 10. That is correct for the middle one. 750, 10. This needs to be 0. This needs to be 250. That's the top one. For the bottom one, this is 750, 10. This is 0, and this is minus 250. There we go. And then we want to do diagonal ones. So let's copy and paste this middle win, duplicate, we'll call it diagonal down win, because that's diagonally down from that side. We'll make this rotated 45 degrees. No, it would be minus 45 degrees. And we actually want to make this a bit longer so it kind of reaches the corners of our grid. So 1040 looks about right. And then I'm going to copy paste that, and this will be diagonal up win, and this will be 45 degrees. Awesome. So these, let's make them in an empty group. Right click, create empty parent, and we're going to call this win lines. Just call this win lines, and we'll make a new script called win line manager. Better to put it in its own script because it will make everything messy, because there's a lot of different win conditions. So edit script, we will just put in here, we're going to need game object references. We'll call it serialized field private game object, and then we're going to want vertical middle win. I'm just going to copy and paste this, and then call it vertical top win, vertical bottom win, horizontal middle win, horizontal top win, horizontal bottom win. Then we need diagonal down win, diagonal up win. Cool. Then that's all of our different game objects for that. And then we need to know, do a public set win line, we'll call it. We'll do a void set win line. We'll just call it set win line, and then we'll do a enum, and we'll call it win line. And the different win lines are non, vertical middle, vertical top, it's not top, is it? It's vertical left, vertical right, horizontal middle, horizontal top, horizontal bottom, diagonal down, diagonal up. That's all our possible win lines. And then we'll go here and just rename that, the ones that were incorrect. So that should be vertical left, and that should be vertical right. Cool. And then we'll do here switch based on our set win line. We'll do win line, win line. And then we'll do that and that. What's wrong with this? Oh, this needs to be public. Cool. Then we can do win line like that. Case win line dot non. And then this is going to look a bit messy, but we'll figure it out. Public void set win line active, and then game object active win line. Cool. So we want to do a loop around all of our different game objects and check each one, and if it is that one, we want to set that active, and if not, don't set it active. So we can just do if vertical middle win equals active win line. No. This is going to look confusing. This in brackets is going to check, is this true or false? So what we can do is vertical middle win dot set active oops, I spelled it wrong. Vertical middle win dot set active is equal to the result of does vertical win equal the active line. So we give this a line to set active. If the line is the vertical middle win line, we set that active. If not, set it false. So we can copy and paste this, and we just need to do this and change it for each one of these 3, 6, 7, 8 different win conditions. So 1, 2, 3, 4, 5, 6, 7, 8. And then we just want to change these. So this is vertical left win, which means this should be vertical left win. This should be vertical right win. And this should be vertical right win. And then we go down to this one, and this should be horizontal middle win is equal to horizontal middle win. This one should be horizontal top win, and this one horizontal bottom win. And these should be the same, so this should be horizontal top win. This should be horizontal bottom win. This is diagonal down win. Diagonal down win. And this one is diagonal down win as well. Down win. This should be diagonal up win. And this one also should be diagonal up win. Cool. So if there is no win line, then we want to do set win line active null. And then we just do break to end that case. Cool. And then we need to type this in for each one of our win lines. So win line dot vertical left, we would do that and do vertical left win break. Then we do vertical right, and we'll set the vertical right win break. This is where Visual Studio is really good, because it starts to know what you're trying to do, so you don't have to type everyone out yourself. So horizontal top, and it might know now, yeah, horizontal top win break. Okay, so horizontal bottom, so horizontal bottom break, diagonal down win, set win, oops, case, diagonal up, set win line dot active, diagonal up win break. Let's just move these case lines so it's a bit easier to follow what's happening. And let's see what's missing. So we've got vertical left, vertical right, horizontal top, horizontal bottom, diagonal up and down. We need the middle for each one. So we need case win line dot vertical middle. And that's that one. Break. Horizontal, we can do case win line dot horizontal middle, set win line active, horizontal middle, and break. So this might look really confusing, but what it's doing is we set a win line, we just pass in the win line, which is all the possible different win lines, and it sets the correct one active based on which one we've given it. So if we go back to our game manager, we're going to want a win line manager in here. Serialize field private win line manager, and we'll just call that win line manager. There we go. And then when we do start a new game, we can call win line manager dot set win line, and we can do win line dot none. So that should turn off all the win lines at the start. And then when we know what's won, because we've checked all our winners, which we do here, we can call the correct win line. So if the top horizontal is the winner, then we know to do winline manager dot set winline dot horizontal top. There we go. And then we can go here and we know this is the middle, horizontal middle. We go here, we know this is the bottom horizontal, so horizontal bottom. Then we go here, we know this is the left vertical, so vertical left. We know this is the middle vertical, vertical middle. We know this is vertical right, which means then we know this is diagonal down, diagonal down, and we know this is diagonal up. Up, save. Awesome. So if we go back to Unity, we can test this out. We go to our win lines, we need to set all of these. So vertical middle win, we know is that one. Left win is the next one. Right win, next one. Horizontal middle, horizontal top, horizontal bottom, diagonal down, and diagonal up. Awesome. Play. So it's crashed because we haven't set our game manager script. We haven't given it the winline manager, which is on our winlines game object. So we're given that now. Clear, play. Cool, so all our win lines have disappeared. X, O, X, O, X, X, X. X wins, and we've got a line through it. Perfect. Restart. Let's try and get a vertical left line. That one works as well. Let's get this. Did we get this vertical? That one works. Let's get a line down this. Yep, that one works. Let's get this vertical. Yep, yep. Cool. So I think that's all the different lines tested. Do we know what happens when we get a draw? Try again with a draw. Draw. No lines. Perfect. Awesome. So I think that's where we're going to leave it. Obviously, you could keep adding polish to it. You could add the option to choose between playing against another player or against a computer. And maybe if you play against the computer, it just chooses an empty square at random. You could also add a tracker to keep track of how many times each player has won. And you could display that on the screen as well. You could add a main menu with a title and different options. You could add online multiplayer if you wanted to do that. You could add different artwork in. You could add different artwork for each player. You could let the player choose their own colors. You could add animations when you put your circle and your X in. You could add sound effects and music. It's basically an endless list of little things you could keep adding extra to make it more polished and more juicy. This has already been a really long video though, so I'm going to end it here for today. You should, if you've been following this, have a working noughts and crosses or Tic Tac Toe. If you've got any questions or comments or ideas for future videos, leave a comment below. Thanks for watching. Goodbye.